Hello everyone, today we will continue with the wiring. Before that I just put the thread chains, now they are installed. It's nothing special, I just mount it in here place with the M3x6. It should be button head. Just took the measurements and unchained, put the end part, screwed it to frame with the again M3x6. Same for the Y belt, and I'm installing the mode for the Z belt because this is 2 screw hole, but mine's are 3. So with that mode I will mount my Z chain. Here they are cooking. A note, I made a mistake. I was telling you that the connector of the stepper motor or the cable of the motor should look to back, but that will interfere with our back panel. So what did I just unscrewed these 3, and while I'm holding the motor from the bottom, I just unscrew them, remove the screws and turn the motors 90-degree counterclockwise for this case. And while again in whole process I was holding the motor, I was giving the support. After that I reinstalled the 3 screws. Now it's okay. As it can be seen, the connector or the cable should towards the middle of the printer for the both drives. This is a small update and small correction. Now first I will place my electronic hardware on the printer. After that I will start wiring. So this is our meanwhile power supply. For the power supply we need to use these connectors, these hinge ones. This movable parts nail is looking to upward while your terminals are in your right hand. So we will use M4x6 for this. We can just place in the dinner rail. Another thing about your power supply, don't forget to select the correct voltage in here. If you are in US or place where the power outlets are 110, select this to 110 or 115. If you are living in Europe and somewhere else where your power outlet is 220, 230, select this one. Don't forget it before energizing your power supply. For the power supply of Raspberry Pi, we need to use with the big holes, and again this movable part I'm putting like this movable nail looking at the terminal. We need to use 3x8. This is also ready. I will continue with the SKR mount plate. We have 2, as you know. We need to screw flat surface together. We will use M2x10 self-tapping screw. I have prepared the brackets. Now I will put the Raspberry Pi and the SKRs on it. I have mounted all the brackets. We need to do configuration with the jumpers and the SKR boards. And after that we will install our TMC2009 drivers also. So it's all shown in the appendix. I think it's not included in the manual, but it can be found on the GitHub page as I remember. These are for the micro stepping settings as I remember. So for all I will remove them as it's shown in the manual. We will install one for each, which is second one from the red connector. Second one from the red connector, and the first 2 when the screw terminals are up. So this one. Yeah, just like that. We need to snip this leg, the outer one. I snipped them all. Now I will place the drivers on the motherboard. So this is the MCU Z, which means this board only will control the Z motors. For that we will put first 4-stepper. For the other MCU, first, second and the fourth, we need to place our drivers because we will use these 3. Since there is a leg in here and there is only one way to put. While you are putting it, be careful about the legs. Just try to align with the holes. And by the way, that's why we are using 2 motherboards. We need 7 drivers. Generic boards are generally 5 drivers, supporting 5 drivers. Now I will install the heater cartridge and the thermistor. We need to be careful about the orientation again. Again, this big part will come to the front. So that means, and these is for the cable ties, for the cable routing, for the hotend parts. So this means the cables needs to come in the right part. Heater cartridge should be installed like this. Thermistor should be installed like this. So with this, we'll place it like that and route our cable via here. Before putting that, I want to make sure about they are working or not. It's easy. The thermistor is basically the resistance which depends on the temperature. That means you can use your multimeter on the resistor section. We can measure it. About the range. Best practice is, if you don't know the roughly value of the resistance, you can start with minimum resolution and you can go up until the numbers appear on your screen. This is the case for me. I don't know what is the rough value for that. So let's see. There is no polarization in the resistance, by the way. Right now I'm holding the probe. In the 200 ohm section, I can't see any value. Now I know that the resistance is more than 200. So I'm going one up, same, one up, same, one up. Yeah, now I see the value. So right now I'm measuring 77 kilo ohm for this resistance. I will just hold it with my hand. So it's going down, as you can see. Now, yeah, these L ranges are colder, so I will just touch it the L range. So it's slowly going up. Now I know that it's working, but I'm not sure these are the right value. I don't know the temperature what I'm applying, and I don't know what should be the resistance in that corresponding temperatures. Heater cartridge. This is 24 volt, 50 watt. Again, I will check its resistance. You can start to 0, but this is another thing. Now it's showing 0 only because our resistance is way below than 0. So in this case, I'm going to drop down the section. Again, 0. Now, I can see that it's right now it's 2000 ohm section. In the 2000 ohm, and I'm seeing a 12 ohm. Since I have 200, I can select 200 to increase the resolution. So if you can see, 12 is rounded by 11.6. We know that our heat cartridge is 50 watts, and we know the resistance is 11.6 ohm. The math is very simple actually. Volt equals to current and resistance. Power equals to volt times current. So in this equation, current equals to volt divided by resistance, and I will put this current in place. So power equals to volt times volt divided by resistance. So I know the current is 50 watts and the volt is 24, and 24 times 24 divided by resistance. That equation should give us 11.6 ohm divided by 50. Yeah, it's 11.52. We measured 11.6 ohm, so that means our heat cartridge is okay. This much is difference okay actually. If we put this value, real value, in here and ask what is power, so actually let's calculate it. So what we said is power equals to volt times volt square divided by R, which means 24 square divided by 11.6. So it's giving me 49.66 watts. So that means that our heat cartridge is not 50 watt but 49.6 watt, which is very okay. All the electronics, mechanical stuff has tolerance, and also all these measurement devices has tolerance. Maybe this is actually measured wrong. What I'm trying to say, this is very okay. And now, since I will run my wire through that way, I'm positioning my thermistor not like this, like this. I mean the cables are on top each other. There is no need to torque these screws. Don't torque it actually. Right now it's holding. Put your heat cartridge. Again, same thing. I will route my wire like this. Carefully bend your wire a bit like this. Tighten these bolts. After that, tighten these bolts. Now we will route our cables. Actually, before tying them, I will again check the values. Yes. Yep. I forgot to put. I forgot to put PTFE tube. Now I will assemble the LCD frame. You need to also insert these pieces. I already inserted while I was trying to put threaded insert in pieces. We will remove this one, just pull it. We will put this in here and we will put our frame and we will put our front. Then we will screw it. And put the knob in its place. Yeah, done. Via the expansion cables we will connect the screen to motherboard. I will use these terminals to distribute 220 main current, and for that I will connect one of the sides to each other. So there will be one input and 6 output, and from this 6 output I will go wherever I need 220. This is for the live wire, this is for the nutter, this is for the earth. I also made a bracket for them. After connecting this bracket to your frame on the electronic parts, then you are just screwing your terminal by M3 by 6. And to make the terminal, I already made one, this one. The main voltage will be coming to here, and I will just connect all of them in here. Actually there's a pre-made bus bar for doing this work also, but I don't have it, so I just made one. So when you feed your main or whatever you are feeding, you can use this for also 24 volt ground, anything. So when you put your cable in here, these all terminals will be closed circuit in with that one. We can check it with continuity test. So preparing wire is simple actually. By the way, use 20 AVG cable. Cut the wire as you need it. And I bought this thing from AliExpress from China. It is not the best, but it is doing its job. As you can see, they are snug on them. Yeah, open your wire, put your terminal in corresponded, it's shown in here, corresponded slot on the crimp. Hold the crimp with the tool. The wire should touch the metal part, reach the metal part. When you see it, just remove your terminal. Now it should be okay. For the rest, I'm just taking the reference from the previous terminal. I'm turning my cable, and where the plastic caps are finished, I'm taking that point to open my cable. They are ready. Now I will put on the terminal. I will put you a link for this bracket. If you want to use terminals, you can download from the link. Now I put my power skirt together, so I will use the Ethernet connection since I have the connector, and I don't have the USB extension, so I put the cap on here, and there is no screw or anything, just these are snag fit. For this part there is a movable part, movable nail, and the other one. Put the other one first and play with the movable one, push it and it will sit on its place. And check your fuse in the inlet. Flat screw, you can just pull it. It should be written on your fuse how much amp limiting. It's up to 10 amp. So if somehow your machine is demanding 11 amps or more than 10 amps, this wire will be broken by itself and you will not receive any power in your printer. If you're sure you have power in your power inlet, but you don't have your power in these terminals, you don't have power in here, it's the case that your fuse is broken, you need to replace it. It's just that much easy. You are just buying these fuses and just replace with the new one. If it is broken, put it back. Now after that you will see power on your outlet of your power inlet. Now we will continue with the assembling our exhaust filter. So for that we have a filter. I don't think this is that much efficient, but however I will run my printer at the separate room, and to be honest, fume of ABS is not giving me headache or something, so I will use just this exhaust filter as a cooling at the end of my ABS printings. Let's start with the fan, since we want to evacuate the air in the printer itself, and this will be placed on the back panel like this, so air will come through here, past the filter, and it will be out in the fan. Because of that, the airflow of the fan should be inside the outside. Generally, they are showing the airflow in the fans on the sideways, but this does not have. However, the front place of your fan where the air goes into fan. I'm guessing that my fan should be placed like this. The label will look at the outer side. Most probably this is the correct orientation, but if it is not, it is easy to flip it, not a big deal. A little bit info about the fan. These fans have DC brushless motors. For example, in stepper motors you see the rotor part where we are placing our pulley. In here, this rotor is not like as a fan, but this is like a cap. So on this cap they are placing this plastic part to create aerodynamic. This cap is rotating on the energized coils. With the electricity, the coils magnets are changing in polarity and sequence, like creating a magnetic field. So with that magnetic field we are creating rotation. With that rotation, this cap is rotating, and structure of this plastic part is creating air. It's pulling the air and pushing the air in the outside. And since it is DC brushless motor, DC motor, I can say, it has polarity. That means that you use your live wire in the red one and GND in the black one, the zero wire in the black one. So you have to plug it like that way. But for example, we said thermistor resistance or heater cartridge is resistance. The resistances don't have polarity. It doesn't matter which wire you put to which. But for example, in our case, the fan has polarity. Of course, our SKRs has polarity. You need to plug correct wire in the correct place. We will place our filter, small door with M3x8. We will secure it. You will use the USB adapter. So remember, this the direct drive is now standard on the Voron. However, you can do the Bowden one. I'm doing the direct version. That means that actually we will have a Bowden tube from here to the clockwork. So this Bowden tube actually is protect our filament inside of the heat in the chamber. It's cooling reverse Bowden, I guess. It's just for that. Our printer will be direct drive, but if you are specifically doing Bowden, it is another case. And it's a common practice in these Vorons also. We will place this on the back of the printer. So it's a common practice that running Bowden from here, it's starting and goes to filament holder. This Bowden tube in the outside is actually for the guiding the filament, so it will be easier to load your filament if you have Bowden in the outside also. I'm planning to put that. So our filter is ready also. This is the left front skirt. I redesigned it. I modified it actually to fit this device. This device is power meter. It's basically measuring the voltage and the current and also measuring the times. So it's multiplying all of them with each other, and it is finding what is your power usage. It's also showing how much current you are demanding and how much power you are demanding, etc. So I designed this skirt like I said. It's simply placing just these are standard threaded insert we need to place, and these 4 is just for this device. Place your device. It's M3x6. It has one push button, and this button is just basically resetting your total power usage. I don't know I will use that button ever. If I will use it, I will just screw this 4 and reset it and place it back. It's not frequently used, so that's why I didn't put any button in here. It's more clean look, and I had to snip off this push button a little bit because there is in that place where the button comes, it's already 1.8 millimeter thickness, so I don't want to make it thinner than it. So you need to snip off a little bit piece of the plastic part, but it's not that big deal. The button is working again. I will start to put my components in the DIN rails. It's pretty easy. It's the movable part, and put your movable part in your DIN rail first, push a bit, clips it. When you release it, it will sit in place. Like I put the first movable part, nail, push a little, it sits. Now you can also slide it. I'm intentionally mount these brackets different each other because, for example, for removing it, for the upper rail I want to push it and unclip it. For the bottom rail I want to pull it and unclip it because there is more space in here, there is more playroom in here. So for that, put these different each other. So that means since our header will look on the back and it's our back side, as we know because of the hole, movable parts in here. So this is for this rail. So and this one is just opposite. So put this one first, pull, and yeah, release it. About SSR, this is the SSR came with the kit. It's rated 25 amps. It should be okay, like I explained in the unpacking video, episode 0, because my power outlets are 220, so I need 2.1 amps or something like that, and this is rated for 25 amps. It's way much than I need. However, since it is the Chinese brand, I don't trust number what is written. So what I generally do, I'm dividing this number, the nominal value, so it is 12.5, and I'm inflating the result, so it's 10 amps. So now I will assume there is written 10 amps in here, not 25 amps. So again, 10 amps greater than the 2.1 or 2.2 amps. So this should be okay. However, I didn't also decide it yet. I may change it in the very near future. However, if you are not confident enough with the electricity or something, just buy a genuine one, buy a genuine SSR. Don't bother yourself with these Chinese brands, and just buy a genuine one and use that one. So for now, I will put it in here. I will do my cabling. I didn't decide it yet. Maybe I can change it. Maybe I can try it. If I try it, I will let you know what is the result. This is our SSR bracket for the DIN rail. We need to use this push thingy. So I will put this pushable part in the down because I have more room, like I said, for improving the thermal conductivity between the SSR and this one, because this will also act like a passive cooler. I don't know how much will it help, but yeah, it's better than nothing. So put this one, put your SSR, screw them with the M4-6. Power supply for the Raspberry Pi and Raspberry Pi. I put the terminals. I also used labels, by the way. I created a labeled Word file, so I will also share them this file if you want to use. I will use this as a cable tag, and from here it will distribute to live wires, from here it will distribute to neutral, and from here it will distribute to earth. I'm planning also put the thermistor for the chamber heating, so I designed this module to put my sensor. I just had this one and I just designed it to fit this one, so it's just a snug fit, nothing is screwed for that, it's not necessary also. And this is for the frame connection. I will mount this sensor to back frame of the gantry. So imagine that the back frame of the gantry and your tool has removing in here. So I will put this next to the drag chain holder, you know, the little module, run the wire in the channel. So I will put this, put it like that and screw in here. Now I will prepare the wires, but first I will run only one wire to see how much wire I need, I mean lengthwise. And after that, with taking this wire reference, I will cut the others. After that, I will connectorize it from here first. I will place it on the cable drag chains, and later on we will start the bottom. By the way, my drag chain came with the kit. It's not opening in any place. It's you need to wire your end to end. Yeah, you can use this, not a problem, but it's not maintenance free. So I just bought another one from the China. Okay, this one is opening in here. That's okay. However, the side where it's open is actually coming to bottom of your drag chain. That means, yeah, you can see in here, these parts are not opening. The bottom parts are opening. So these parts are opening. So again, it's slightly improvement, but it's not what I want. However, for now I will use them. I thought that I can just unscrew this one, put the direct chain on the other side. I will open it, run the wire inside, put it back my direct chain. Same thing for the Y direct chain. For the Z direct chain, I don't need to do that because it's both sides accessible. Also, it's the outer side is opening. So after that, like I said, we will start for the bottom. I created my reference point, by the way, and this is the 20 AVG wire. So remember that on the tool head for the heater, you need to run 20 AVG wire. For the rest, you can use 20 AVG, but for the heater, you have to use 20 AVG because the heater will demand a lot of current. If you remember, it was roughly 11 ohms. So, and we will provide 24 volts. 24 divided 11, if you say 10, 2.4, 2.3 amps only heater. So that's why we need to use 20 AVG for the heater. The rest you can run 20 AVG. Another thing is I'm using ribbon cables. Disadvantage is it's not colored, but I created labels. I can quickly check the continuity test. Another thing is this is silicone wire. After direct chain, developers are not recommending to use that. Developers are recommending the PTFE isolated ones. However, I will try my chance. I hope it will not give me an issue. I will run them maybe in the next update, or if I see major issue, I will order a PTFE one and run them again. But to be honest, I am not expecting any problem. However, I could be wrong. I'm not sure. I didn't test it with it, so it's just my opinion, but I will try it. If you are using also silicone wire and you are not sure about that and you don't want to buy again another cable, you can do one thing. You can arrange your old cable. Before putting your cable on the direct chain, you can use cable sleeves. You can use this cable sleeve and run your cables inside of it. And after that, you can run your wire on the direct chain. I will use this one as a reference. I will cut for the other stuff like thermistor, fans, and stepper motors, etc. Now I'm connectorizing the Hotend part, the afterburner part side, and I will just show you how I am doing, and you can take it as a reference. Just measure your wire and cut it. After that, remove the insulated part, adjust a little bit. This is also a little bit long, but it's okay. You can keep it. Normally, your wire should start from here. Your insulator should end here, come till here. So it is your isolated part should be removed that much length. Another thing is, since this is a receiver, this will demand current. This will not supply the current. In here, you should use male type of connector. In my case, I am not using the connector that came with the kit. I already bought a set. In that case, this is your male connector. So this will be exposed. And since it will not supply any power, it will not electrocute you. However, think about the normal plug. For example, it's just normal power plug and it's the male side. So I can touch it because this side will demand the current. This will not supply a power or current. So it's safe to touch it. But if you think about your outlets, these are the female. These are providing the power and current. So, but you cannot touch it. Yeah, you cannot touch the inductive part, any inductive part of it. You can reach the holes where you are putting these parts. But for that, you need to do it especially, for example, like with your controller, you can check the live wire. If you see the power outlets, these are female, and you cannot did any the inductive parts are not exposed. So that's the logic. If it is providing power, if it is not demanding, if it is providing power, you should use female side of connector. But if you are providing power and if you are providing current, you should use male side of the connector. So in our case, these parts will be male and the cable which is coming from the motherboard will be female, because this cable will have the current. This is just a common practice. If you used, or if you want to use vice versa, for example, if you want to use male in here, I don't think it can cause issue, because it's just a 24 volt and it will maybe tickle you, maybe not tickle also. But it's just a common practice, and applying the common practice in your project is a good thing. It's a good habit. So that's why I'm explaining. For the crimping hits, I'm using again this China tool, crimper. I have a lot of this head. Your connector has two hinges. So first hinge for the inductive part, second hinge to hold the insulated part. So if you see this teeth, one is deeper than the other. The deeper side should correspond with the outer of the pin. Before applying your crimp on your main tools, just try with the cable, and so try a couple, and after used to that, okay, you can do it, just start with your tool. For example, I also did it. This is just a excess wire and I tried it. Place your pin inside the tool. If you see metal part is in the upside, hold your pin with tool. Place your cable inside the pin and crimp it. And while you are removing the pin, try to apply the force in direct vector, not try to apply your force like diagonal. If you see, this is a bad example actually, because the insulator of the wire very thin, it's not fitting in the pin. Here you can see, you will see a small nail in your pins. This and this needs to be fit through. If you can see, the upper one has a little bit extension with this small nail. So you will orient it like that and place your wire. I will use also delay module. This is the 2-channel one. For 1 channel I will use for controlling the LED. I'm planning to put LED in my build. For the other channel I will use to control my main power supply, which means that I'm planning to Raspberry Pi powered all the time via Octoprint. There should be a plugin, as I remember. Via Octoprint I will control one of this relay and I will control the main power supply. With that I will give or cut the power via Octoprint for my printer. So for that I designed a little bracket, hold the relay on the DIN rail. I will put its link on the description. If you want to use it, you need to also print this pin clips. It's the same one with the SKRs, so it's same method exactly. You are mounting these two pieces together and clipsing it. I also ran the wire from the tool head, from the motors, from thermistor. All the wires are here now. Now I will again measure the distances. By the way, as you can see, it's a lot longer than I need, but I would also recommend you to do like that, because it's better to cut a longer wire cutting short than try to replace this wire again. By the way, in here I will not use any cable channel or cable sleeve or etc., because I don't like it in the electronic compartments. And second thing, it's not maintenance free solution. I will just run the wire I will create routes for the wires in a convenient way, and I will run all of them in all the wire on these routes, and if I need to replace something I can directly play with it. And to be honest, if I can, I will replace this place and with the opaque one to show the parts in here. Why should I hide it? It's I think another on the pet of the wires I will use these parts. I will also put its link. I created this one because, as you can see, this is a flat surface. I designed it for the ribbon cables. So with this hole I can use the zip chain on the ribbon cables. It will not try to give the ribbon cables like a circle. So I think it's more protective for the ribbon cables. So because these ones are, since the surface is small where you are putting the zip chain, it will try to, with the zip chain, it will force the ribbon cables circle shape. I just drew a model and I printed a couple of them. I'll use these ones. I will put tape on it, stick on the panel where I need, zip tie them. That's all. I will not use these ones. I wired the power skirt. I plugged the energy cable. You need to be careful while it's plugged because these are exposed. You can electrocute yourself also in terminals. Now I will check the wiring is working or not. So I go to caps. I need to be careful in terminals also. So now I will check it. To check it with the multimeter, since we will measure alternative current, you should use this symbol, the sinus wave. And like ohm, it has also resolution. And I know that my power outlet is 232, it's 220, 230, so it's bigger than 200, so I will use 600. Right now my switch is closed, so there should be no electricity. I hope you can see it. Now there's electricity in here, and when I close it, let me unplug it. While it's plugged, switch is closed. Okay, there is no electricity in here, but there is electricity in these pins. So the switch is not protecting you in all ways. So be careful. This is This is not like a 24 volt DC. 220 can hurt you. You need to be very careful. And another thing, in every step, do the measurements. For example, I just plug these terminals. Obviously, they have to work. But again, I checked it. Later on, for example, I will connect my power supply. After connecting it, I will directly check the output and the input. Because in that way, if you measure while you are building in every step, if you test it in every step, that way, if there is a problem, you can directly point out the problem. For example, after wiring the power supply, you've seen that you cannot getting output. So you can say that, okay, there's something wrong with the power supply. And you can check the input voltage. Okay, there's the input voltage, so it's definitely with the power supply, like that. So in every step, while you are doing the cabling, especially while you are doing the main power, do the test and measurements. Wiring this plug, you want to note down this while I'm explaining to you, because you will need it. You need to use this type of terminal. This one, so it is simply sliding in the pins. You will have 2 pins in here. You can understand the orientation. These parts are chamfered, this is straight, and the button is here. So you can see the orientation and probably understand what pin am I talking about. So in the left part where your power cord's in, you have 2 pins, and the third pin is going to the fuse. So that means this pin, the output of the fuse, it's your live wire, and the next to each live wire, it's your neutral wire. The last one, which is on the right side, it's your earth wire. You will see 4 pins in here. So the bottom ones are input for your switch. This is for the switch. It's controlling both live and neutral. Bottom one is your switch input. So you need to come here from your inlet, live and neutral. It doesn't matter which one are you going. Went the left to left, right to right, but you can do vice versa. It doesn't matter. What is important is when I use the left one, the other 2 pins. The other 2 pins are output of the switch. So if I'm using the left one for the live wire in here, so again the left one will be my main and the same thing for the neutral. If you plug the live wire in the right one, the right out will be your live wire. So be careful about that. And this is simple switch, like I said. You can check it with the continuity test before you plug it. And this is earth wire, like I said, where, for example, our bed earth connection will come here. Yeah, that's it for this one. Now I will use these terminals, this one, and this one. I will plug my power supplies. Since I want to power all the time my Raspberry Pi power supply, I plug my Raspberry power supply first. Let's check, is it giving us 5 volt or not. This time we will use, since we will measure the DC, this time we will use this one, the straight line. And we know that it's 5 volts, so 20 is the nearest selection in here. I'm receiving 5 volts as expected. I hope you can see it. I plug the USB cable for the Raspberry Pi. It's just pretty straightforward. And when you cut the USB cable, you will see 4 cables. You need to use red and black. Red is positive and black is negative. So I just connected the corresponding slot in this. And if I connect, yeah. Now let's try the Raspberry Pi. Yeah, we see the LEDs. And another thing is we need to connect the ground wires of these 2 power supplies to each other. Cable for that I crimped and put in on the ground slot in here. So I will connect this in the ground wire of this power supply. We need to do that. Now I have also plugged the main power supply. We need to put 200 since we want to measure 24 volts. Yes. If you will also use relay between the main power supply and main, so you need to wire like this. For your neutral and earth connection will be directed to the terminal. It will be wired directly to terminal. But for your live wire, from terminal you need to go to the relay's common pin. Then after that, from normal open pin to your live connector on the power supply, you need to wire between them. From terminal to common pin of relay, from normal open pin on relay to a live wire connection on your PCU. Since I'm not configuring the relay. I plug the normally closed one to test the pieces and the power supply itself. Later on I will change to normal open one. And if you are not using relay, again it's the same. Live and neutral and earth connection will be from the terminal, same. And like the live and if you are not using relay, just put your wires from terminal to your PCU. That's all. The difference is if you are using relay, you insert the relay in your wire between the terminal and power supply, and you want to use common pin, the wire for the wire which is coming from the terminal, and the normal open pin which needs to go to the power supply. I wired the power for the SKR boards. Let's power it. Let's start on. Yeah, that's a good sign. Now I know the wires looking a little bit mess now, but after wiring all the things, I will do the wire management with the clips that I showed you. There is only one thing remaining for the main power wiring, which is the SSR in this case. And that I need to put a live wire in here. I need to come from the terminal to first slot of the SSR. Later on we will connect the one of the wire in here of that, and this will be the signal. So only one wire left from the terminal. I will do that. After that I will connectorize it, cut it in the length and connectorize them. As you can see, I did the wiring. It's a little bit mess now. Right now I only plug the essential parts, standard parts, like I said. For example, I didn't plug the chamber thermistor yet, and I didn't put the LED connection yet. First I want to run this printer and see everything's go well. After that I will do the modding, if I will do, but yeah, I will put LED definitely. Regarding to this is the thermistor that came from the heat mat itself, from the Kinovo. Like I said, for now I'm not using it. I put the thermistor that I put on the aluminum bed. It would really hard to explain you where the cable goes and there, so I will not do that. Instead of, I will do another session which I will do the drawing for the main parts, and from here you will easily see that where the cables are going and where you need to plug, etc. for the mains part, like I said. But for the SKR connections, there is already one document that I showed you earlier. It's very clean and understandable, so you should use that. While you are doing wiring, I also used it. So instead of explaining me this motherboard connections, it will be pretty easy for you to follow that document, which can be found under the GitHub of Voron, as I assume. Otherwise I will put its link. Since I will run couple wire like LEDs wire, because of that I didn't fully tighten these zip ties because I'm routing the cables. And couple remarks, I used labels, so that is helping me to see which cable is going where. And since I'm using the ribbon cables and it's only black, so I'm using these heat shrinks. So with that, now I know that the upper cable is the positive wire, down one is negative. It's a small trick that you can also use if you are using single colored cable. I tried to place the hardwares roughly suggested in the manual, so I also placed like this. So this is our 24 power supply, this is our 5-volt power supply, and this is our SSR, our bed and power connector and thermal fuse. I will explain this in standard way. I mean, I will not add any terminal or Vego or something like that. Yeah, let's start. Now, we should start with the power skirt. So in power skirt, 3-pin, which is directly connected to your cable, I can say, with plugging the back. And this 4-pin is connected to switch where you are controlling the on off. This one is the earth, and this one is live, and this one is neutral. So what you want to do, first you want to connect your live and neutral to switch. With that you can control the power on your printer. So for that you need to wire this one in here or here. It doesn't matter, as I know, but for example, I think it's always the case, but just check with your multimeter with the continuity test. In my case, these were the same pin. What I mean, when I power on, these two became in closed circuit and these two became in closed circuit. So that I should wire my live wire, one of them, and neutral wire. So your live wire and your neutral wire should be, yeah, something like that. So this is the input we used as the input, these two. And now these are the output, will be the output. This will be the neutral, since we used this pin for the neutral, and this will be the live. So if you see your terminal of your power supply, this is the live one, live input, neutral input, and the earth input. And these three for the ground connection for 24 volts, these are the output, and the three are again 24 volt for the yeah, the positive outlet, positive outputs of the power supply. So what you want to do, match the cables. I mean, live to live, neutral to neutral, and earth to earth. Since there is not another terminal for the live wire or neutral or earth, we will use this input as a distributor. So what I'm trying to say, so we will connect our live wire in here. Yeah, like that. Right now, this point is a distributor for my live wire, for my live. It will be distributed to bed, SSR, the other PSU. Let's continue with the live wire first. Okay, I will take the live wire and connect it to SSR. This pin, the pin of, yeah, 2. If you see, it's already mentioned that it can handle for 80 volts. So in my case, it's 220 I will use. It could be 110 if you are in USA or UK, or if your power outlet is 110. So it's this side we should use for the live. Then from the input in here, I should go to the thermic fuse. So I will drag my cable from the SSR, and I will go to the thermic fuse. So, and this thermic fuse will be placed on this either on the silicon mat or on your aluminum plate. Now, then we came from SSR to thermic fuse. From thermic fuse, we will go to the bed. So the white wire is our power input for the bed. So it doesn't matter which one you are using, but for your safety you have to use thermic fuse. Then, since we gave the live input in here, the other white wire of the bed will be our neutral wire. But we will come to neutral at seconds. No, first let's finish the live wire. Okay, and for the last, we will take the live input from our distribution point and came to our 5-volt input. If you see in here also, it's a live input, neutral input, and earth input. And these V minus is your ground cable, and V positive is your 5-volt positive output. So we will go to the live one. So yeah, if I'm not missing anything, this is the live wire will be distributed like that, and that was all for the live wires. Now let's continue with the neutral. So again, I will take the neutral and connect it to 24 volt PSU. Again, this will be our distributor. From here, I want to go, of course, to 5-volt PSU, and this will not go to the SSR because SSR is like a switch in here. It's like lamp switch on your room. It will do the just switching for the bed. That's all. So it's connected to serial. But the other wire from the bed should go to the neutral. So I will take the neutral from the distributor and go to the bed. Yeah, neutral again. It's like that. That was all. And lastly, our earth wire. Again, I need to go to 24 PSU first because that point will be my distribution point. I will take this neutral wire and go to the, of course, 5-volt PSU. Then after that, like I explained in the episode which I'm doing the bed, you should have one terminal on your aluminum plate itself for the earth connection. So from that point, like aluminum plate earth, let me indicate it like this for the earth connection. There should be a terminal which is connected to your aluminum bed with the screw. So from here you need also earth connection. So like that. This is how you need to wire your mains. If you want to add a terminal between this power connector and the devices, or if you don't want to use these terminals as a distributor, you can just add the terminal like me, which is very easy. In that case, you only need to add the terminal itself, the between in this case between the 24 PSU and the power plug. So there will be a terminal. Let's assume this is the terminal. Instead of going to 24 PSU first, you should go your terminal first. So from live, you should go one terminal. Then let me clean this one. Let me explain the terminal connection for the live one. It will be same for the others. I ran my live wire to terminal. So since it's touching the other outputs or the terminals, you want to drag another cable to 24 PSU. Then after that, take another cable and go from the terminal to your SSR and take another one, put it to your 5-volt PSU. Now, this is your distributor, not this terminal. So if you want, you can go that way also, but you don't have to. You can use this one. There is no harm with it. This will be same for the neutral and earth connection. You will put another terminal and you will drag your cable to this terminal, and from here you will go to your 24 5-volt and your bed. For earth also it is same, but if you don't want to use terminal, can I go back? Let's see. Yeah, this is your main wire connection. For the low current wiring, which means the other wiring like your extruder, your heater, the all other elements, for that I will not explain you like I said because it will be harder for you to me explain instead of following this manual. So I will strongly advising you to follow this manual. In here, it's all clearly shown what you need to do. So I also explained this one. You need to spin one of them and you need to rearrange the jumpers. Yeah, this is easy. And here you can find which elements, which hardware should going where in the motherboard. So what you need to be careful about, for example, this is for the MCU XYE. In the MCU XYE, you need to put your hot end fan in this pin, parent cooling fan in this pin. If you see the other one, the MCUs, that the same inputs were used for different elements. What I'm trying to say, if you put your exhaust fan on your MCU XYE instead of MCU Z, when you or clipper set to board open the exhaust fan, it will open your hot end heater. It will activate your hot end heater. Yeah, this is not a good thing as you can imagine. So just be careful which wire, which elements goes to which MCU. Just be careful about that. If you use this manual and apply to your printer, it will be really easy to commission your printer because otherwise if you plug your print cooling fan the first socket instead of the second one, you need to change this pin inside your config. So you need to find the SKR board schematic and you need to find which pin is it, and you need to change into your config and save it, etc., and test it, etc. So
What I'm trying to say, just follow this manual, plug your cables according to these pictures, and you're good to go. And be careful about motherboard, which one is going where, etc. Another thing, while you are connecting your probe, don't forget to add your BAT85 diode. Yeah, this is basically for protection probe. So you have to use it. And if you see the BAT85, there is a one black line on the one of the side, and this one black line should face to cable which is coming from your probe, not the motherboard. The direction of your BAT85 does matter, so be careful about that. Now let's assume you did the cabling between this two pin and this two pin. After that, just test it with your multimeter. Select the correct position with the switch. Bigger value than 220 if you are in Europe, or your powered outlet is 220 in the AC section, which has the sinus wave signal. This one. Plug your printer and measure this two pin. If you see 220 or 110, that's okay. Then close your switch. Again, measure it. If you are getting zero, then if it's affecting what I mean, that's okay. And after that, unplug your cable. Why? Because, okay, switch can control this two pin. However, while your printer is plugged to power, these two, and these two will have power, will have current. So it can create a dangerous situation. So that's why you need to unplug your cable while you are doing cabling. The thing is, most of the devices, I mean, we are plugging a two manual power supply. This power supply has protection, it can protect itself up to a limit. I don't know what is its limits. I didn't check the data sheets. However, there is no protection for you. You have to provide the protection for yourself. So that's why in every step, test your devices. As a second step, after you cable your main power supply, plug your power cable, switch on, and test the output. Now for this output, you need to select the upper value from the 24 volt, and it should be the C section. So in here, you should see a DC and like these symbols. So you should get a 24.1, 24, 23.9, etc. These values. Then when you see this value, close your printer, unplug it, and run the SSR or run the 5 volt power supply. Again, plug it, test it. In every step, if you test it, it will be easier for you to diagnose if there is a problem, because you will know that there is a problem with the new device because the older device was already working. So that can be helpful for you. And yeah, that was all for the wiring. I hope I can clearly explain to you, but if you have any question, don't hesitate. Feel free to ask in the comments. I will happily answer that if I know. Yeah, that was all. And in the next one, I will start commissioning my printer. I will test the steppers and stop and all the things. And after that, I will try to home. So let's see, finger crossed. And again, thank you for your time. Thanks for the watching, and consider to be a subscriber of my channel if you are enjoying my videos, and if you want to see the next ones. And yeah, take care. Bye bye. See you in the next one.